Testing.
But also hand up also like
Yeah, she's not the most.
exactly.
You must pretty much carry the. Things and show you what other people. So that is the OpenAI gym. You ever been there? Do you have a laptop? Oh, pop it open. And just head on over there. And what this is this is the biggest reinforcement learning initiative in the world. Okay. And these are challenge problems that are posted, and anybody can try to solve them. And there's 100 of them. So like the guy who's the head of autopilot for Tesla was like one of the young scientists that started this thing. And it's just got all these tremendous challenges. So, we're going to develop the skills so you guys can tackle this problem.
Yeah, another predator was happening on my computer and like crashed. That was really fun.
Oh, I created a program that was just being really, really dumb. And all it did was display what one person rolled over and over and over again because it was in a wild true loop. And the condition was never not going to be true. And so it was like, you rolled a 6 over and over and over again. No,
I intentionally
I stopped
I
it.
intentionally made a program to crash.
No, there's a button, and Jake grabs it, I was like, stop, because I was like, oh, I'm
I
gonna
made one to intentionally crash my laptop. I made a program that was like a wow true loop, and it just made different squares and squares varying size and color. Just as many as it could on the computer.
The thing is, like, I just accidentally did that enough that last year I didn't they can play something that would. Yes, yes.
I wrote a program that caused the school's computer to catch fire.
Oh, nice.
Because it was a common
Yeah.
which you might want to Google that, and so it had a cassette tape.
What?
So you run the program to rapidly turn the motor.
Yeah, well, kind of spam, man.
But it was really funny because like
It would like just like melt the.
I'm crossing conversation.
That's really.
We were like,
So
I work with
I did build a
Yeah, and so I go to work this morning, it's like
You're
7:15 in the morning, and I walk by his mom, and she's like, so, what? Because I guess like all your parents know each other,
Together.
or most of your parents know each other.
I've never seen either of his parents.
Okay,
I've told those.
we just
Oh
remember.
god, I finally
Okay, but they're actually
I finally got my thesis.
Good.
And then,
Anyway, it's a little bit like a conspiracy, but that's okay.
That's good. Back into it, yeah. Your college essay works like that too.
well, because I wrote it, and my teacher
Anyway.
made me function in a way
It's a brick
contrary
like
to
that.
how I would like to do my work, because he assigned the thing, and then
It's the only thing that
said,
happens.
for the next class, you need to have no less than a page and a half written. That's not how I function, like, I just kinda like go for it. And it wasn't due for like another week and a half.
I can't help you with money.
So I write,
no,
I wrote like a
You
page and a half
need- you
filler,
need
basically
you
just
to
summarizing the
exist so we
plot of
can
one of
set
the
up
stories that we
financial
read.
stuff to I exist.
Incredible. He didn't
That's
even
one
get
problem solved.
he
Here I am,
said word
solving
counts, so I
problems.
had, like,
That was
200
easy. I thought it would
words
be a
of
lot
summary.
more.
When
Is there a thing we need to be
the
done?
like book when the story was
Private email, or who's telling you?
And
You're
then,
probably gonna hop in it right now.
Is it Google?
and then I finally
So
realized
yeah,
it was
you can just open it like a Google Doc. So,
Right, everyone does.
No, the
They tried to.
I put my copy of something like that.
Did I put one share
Mr. Dawes.
Was that get these notes?
No, yes, you could. Yeah. Also, we can call you that, and you just say that.
Do you know why?
That's what you're doing.
Yeah.
Yourself.
Yeah.
It's like, see. Andre is talking about it.
yeah.
Don't open original.
But he ultimately.
No, you have to click on the link there. You don't.
Hey, you found it. It causes me
That's okay.
a lot of issues when people try and micromanage the way that I like want to write my own essay, because I'm like, this is complicated and you're paying English class, so physically I know how to write, so just let me write.
Everything is dark mode.
I've been writing for freshman year of high school.
It's such a stressful guy.
Yay.
All of them.
It's the.
Freshman year, her roommate has a kid. And then she, so their father is in the military, so she's living in like the sheep.
I'm waiting for the call.
And so he's very confused. So my mom and his mom were like, "Oh, we're going to the club." And so we were like,
I totally forgot about it. I woke up on Sunday and
Like what's going on?
yeah, I was like, I woke up and I thought I well, that was how I figured it out. It's like, I started and then I was like,
Back and forth.
A couple more minutes.
Oh, I thought it was gonna be excellent. Like, constantly. He's going in and out all like, I don't know, very another one. It's one of the answers. Wait, did you put the I just had to boil water.
the way that we worked out, like he's taking that job, but being part-time. A few more hours a week. The other way to do that can be sort of disruptive. Like this and everything else. It was more one yeah. So I was working 8 to noon. So now we're 7 to 8, which is fine.
No, but since there's like a small interval, it's totally
But between that
we also have a question about Michael, because he said he would help
a little confusing.
You hop right in.
Oh.
Hey, couple minutes, we'll get started.
Hi, I'm Jeff.
Where is that?
Jeff is the one who does the.
Is water the other one?
Oh, yes.
Yeah, just over there. Water, that's right. That's OpenAI, yeah, that's OpenAI's website.
Oh, okay.
In fact, I wanted to show you before we get started, what a big deal that is.
But it's not Jim though.
And of course I forgot.
Did I do it?
No, not Jim. Jim. The other Jim. The workout Jim.
Look, it's that.
Oh, G-Y-M. God.
It's that OpenAI.
Well, we had.
Oh.
Do you know Dota? Do you play Dota?
Oh, they made one big
Yeah, because they built the Dota 5, the
Wait, really?
AI that plays Dota.
First year mark.
Which is, whether or not you play Dota, and AI that plays Dota is like next to impossible. That's
crazy.
What is
Yeah.
that?
It's a no-go game.
Multiplayer games where 5 people try to capture the flag.
Apparently, like, there's no way it's like that much you doing the I know it is, but I don't know how to play it. The mobile. Yeah, so you run against 1, 2, 3, 4, 5.
And their exact words, honey glazed ham, meatball and mozzarella sub, and caprese.
Oh, yeah, the 20 per They're all bound with the same. I guarantee you. There's 4 from Corso. Yeah, all like robot that shit is that and have to be a tank. That's my goal.
I don't know, it's
Like,
talking
scroll
about
up to
pesto.
the. I can't scroll up, it's the weirdest thing.
I've never had
Drag. You cannot. You literally put it on just on the middle now. You
Yeah,
cannot.
you can.
Just drag.
cannot.
Drag. Button 3. You can't drag.
Oh, goodness.
It's stupid. Why would you be going on it? I don't know. You can't design stuff. My design is zero. I think if it's a hey, I want to go drag. Yeah,
That's just kind of where I'm
What?
at.
No. Yeah, I'm gonna go let me I'm gonna go think of this and have it be like a tank.
Oops, did I put this on? Yeah, I know.
light on the front?
No, we're trying to YouTube for some folks that are like way upstate.
Press and hold the button on the front. Nope, on the front.
You sound like a
Upstate New Hampshire.
I don't even know where
So we have started coordinate our efforts, believe it or not, slightly with computer science teachers. So the computer science teachers can't all get here. So we try to at least record what we do, just in case somebody wants to look and say, how the heck did you do that lesson? Okay. All right, we can. I'm going to steal a stool.
Then you know it's not them because they turn around and you
from
see
Berwick to get food. Well, first of all, stop then to get food and then I'm going home with one of
All right, Mr. Ilya, did you start that? Huh? You going?
Maggie and I already did that.
You did?
Yeah, during this CCC time, we were like printing 13 copies, like did the whole thing with Greta. So you're good.
Okay, we'll get started. So a couple quick things for anyone who's not been here before, right? I'm Michael, this is Jeff, that's Ilya. Ilya, there you go. And we go by Michael, Jeff, and Ilya, okay? So don't worry, just call me Michael. Everybody does, okay? Stop that. And feel free to ask questions and expect to make mistakes. And we make tons of mistakes, and that's how we find our way forward. So don't worry about anything. We're going to study some machine learning. And the thing that I want to stress is it's mostly about ideas. It's not mostly about code. You're going to discover that some really giant ideas can get expressed in some really simple code that isn't very long, it isn't very hard to understand. So a lot of what we're going to do is think about how things work. And some of that is going to be in Python. So one of the things that I always ask at the beginning is how many of you have ever even seen Python? Which no is an okay answer, just curious. A little bit, no? Mostly. Okay, good. So if you haven't seen Python, we have some stuff on YouTube, and we've got some other places you can go, or you can hop in the Discord and ask questions. You probably pick it up pretty quickly, but don't worry if your Python is a little bit more or a little bit less than somebody else, it's not going to matter. Okay? So now we're going to study a part of machine learning called reinforcement learning. So just very quickly, you can divide artificial intelligence as like this gigantic field of study, right? You can kind of divide it in half. And one half is machine learning. One half is other stuff. And the machine learning piece, you can divide into pieces. The thing that looks at pictures of cats and says that's a cat, that's not what we're doing. That's a totally wonderful study called supervised learning, and someday we'll do that, but we're not going to do that right now. We're going to focus on a part of machine learning called reinforcement learning, and it's how you play games. Okay? So reinforcement learning is how the computer plays Go and beats the world champion. It's how the computer plays chess and beats the world champion, which was a computer program, but oh well. Okay? So that's where we're going to hang out, in the field of reinforcement learning. And my goal for everybody in the room is by the fourth week or so, you can start to think about doing this on your own. And the place we do this on our own is at the OpenAI gym, okay? Which, has anybody heard of OpenAI besides me talking about it tonight? So, thank you. OpenAI is a giant worldwide initiative that gets a lot of attention a little bit past high school. And it is to get people to come to understand how reinforcement learning works, because there's a giant need for people who understand how reinforcement learning works. So they built this website full of challenges. And you can go to that website and pick a challenge, and some are simple and some are less simple, and then they get really crazy. Okay? You can try them on your own. So if we have a really good 3 or 4 weeks, then in week 5 and in week 6, you'll each get to pick one of those challenges and take a crack at it, right, with the help of everybody else in the room. And that's where we're headed. So my goal is to turn you loose, okay? It's to build the skills so you can do this on your own. So before I continue, the restrooms are out there, the water cooler's back there. Does anybody have any basic questions? Oh, these things have Chromecasts on them, so if I say to you, put your screen up there, That means go to Chrome and find the cast in the menu, and this is called screen left. That's called screen right. Okay, so that way I don't have to run around. Good. You ready? Okay, so here's the challenge. Next 3 weeks or so, we're going to create one computer program that can solve at least 2 problems that may not seem like the same problem right off the bat. So we're going to discover how to create a program that learns. Okay? So the first problem is a maze, and the second problem is playing tic-tac-toe. So we're going to start off with just, I drew a really lame little maze up there with a start and an exit. You see it? And I drew an equally lame tic-tac-toe, right? And if I asked you, hey, could you solve that maze? Could you get from the S to the E? Right? Could you do it? All right. Take a while? Yeah, okay. And if I asked you if you could play tic-tac-toe, can everybody play tic-tac-toe? Now, if I asked you to write a program to solve a maze, could you at least give it a try? Probably, right? And if I asked you to write a program to play tic-tac-toe, anybody ever try to write a program to play tic-tac-toe? Okay, right? You could try, right? So here's my big question. What would your maze program think about? Anybody? What's the first thing your maze program would have to know?
Knowing what's a place you can go and a place you can't go.
Exactly, right. So what's the nature of the maze? What else would your maze program have to know?
If it did a good thing or a bad thing.
Yeah, right. Did it get to the exit, right? It might want to know that it can move up, down, left, or right. Right?
It needs to know the actions.
Yeah. What would your tic-tac-toe program want to know? Anything, doesn't matter. It's not a trick question. We don't do tricks here. Anything. If it won, good. What do you think?
Like what it needs to prevent.
Yeah, like it wants to keep you from getting 3 in a row, right? Because you're far enough along to know that you can't win, so you got to not lose, right? Well, he said what it needs to prevent. Okay, so you think about tic-tac-toe. You got X's, you got O's, you think about tic-tac-toe. Okay. What we're going to try to do is work in a world where we don't have to think about those details. So what you guys were doing just then is you have what reinforcement learning people call a model, like a mental model. You know what a maze is. And you know what a maze is because you've seen one before, right? If you'd never seen one before, you wouldn't know what it was. It would just be a thing, right? You all know what tic-tac-toe is because someone taught you to play, right? If you didn't know what tic-tac-toe was, you know, it's just some thing, right? Well, the goal of reinforcement learning is to treat everything like it's as generic, as general as possible so that everything's just a thing, so that when we build an algorithm that learns, it can learn to do more than one thing. So this is the biggest insight of the entire study. We've got to break problems down into their most general form so that our programs can solve lots of different problems. Now, that kind of sounds odd, maybe, so I'm going to try it, okay? So who wouldn't mind playing tic-tac-toe? I guarantee I'm going to lose. Okay, come on. Is it Sophie or Sophia? No, not you. Sorry. Is it Sophia? Michael. So here's tic-tac-toe, right? And we're going to get these markers that sort of work, right? And we're going to start by playing the way people tend to play, okay? So here, you can be green. Okay. And you want to go first? Let me go first. Okay, so I'll put an X right here. You put an O, and I'll put an X. You put an O, right? And I'll try to block you. Okay. I'll do this just for fun. So no, you can win. See that? Wow. So I did that. Now that's because if you had the expectation that I wouldn't do that, but that's okay. Tic-tac-toe. Now play like a machine that has nothing but time to learn how to play, okay? But has no concept of the game itself. So how would that machine behave in the very first go? So this is called tic-tac-toe, right? And all I know is that there are 9 things I can do. What are the 9 things I can do? In one of the spots, right. You go ahead and go first. I say, well, I've never done this before. I guess I'll try the first one. Just do anything. I mean, I don't know. I'm going to try the first one again. All right, so now, no, seriously, this is how it works. All right, so now what happens? It's not the end of the world. What happens? I lose. You're like, oh, dude, you lost. That's not a good idea, right? That's fine. So then your computer program goes, okay, note, don't do that, right? Well, then if you play 100 million times really fast, guess what? Yeah, you learn how to play, right? Okay, so now if you were the computer and I asked you to solve the maze, you would say to me, what am I allowed to do? Ask me.
What am I allowed to do?
You're allowed to move, no, not even move. You're allowed to do 1, 2, 3, or 4. You pick. 2, okay. So in my world, we'll say this is 1, this is 2, so now you're here. You're allowed to, but you don't know that. All you know is nothing happened. You're allowed to do 1, 2, 3, or 4.
1.
Okay, so you lose. Good. Don't do that. Okay, good. So thank you. Now we're going to use the actual computer to solve the maze. Okay. So the idea there, I hope, is sort of clear, which is we reduced those two problems to what action am I allowed to take, and did it go either well, did it go badly, or did nothing happen? And we can take a lot of problems in the world, chess. I don't play chess, but do any of you guys play chess?
Oh, yeah,
Or anyone know what chess is? Good enough. Okay. So you can take the entire problem of chess, and Google has a computer that took just that approach, played against itself, and it is the world champion. Okay. It played a lot of times, but that's essentially, wasn't quite that simple, but that is essentially what it did. It didn't know the first thing about chess. Okay. All right. Now, our computing environment is Python, and we're going to use something called Google Colab. Okay? And the reason we use that, it's just like Google Drive, it's like a Google Doc. You get your own copy of what we're doing, you can mess with it, you can keep it, take it home, do whatever you want, and you'll bring it back next week and you'll still be, like right up to date. So has everybody figured out how to hook to the Wi-Fi? Because if you haven't, it's LoisLab, and then the password, of course, is LoisLab1, because it's super secure. Lowercase LoisLab1. Try to hook to the Wi-Fi, okay? And I will try to go to the Colab. So I sent this out by email, and I put it in the Discord, and I put this everywhere I could think of. How many of you can find this thing? Or how many, I'm sorry, can't find this thing? That'd be a better question. So take your time. Try to get to this thing. So the way Colab works, it does two really great things, okay? You can make notes like words and write Python in code, and they both go together. This is Google's computer, right? So we can't run out of compute. Right, no, we will. We'll break it eventually. Okay. So go ahead, take your time. Ilya, do you want to make the rounds, and anybody who's not found the Colab, maybe help them out?
How those were lost.
Right. Ilya, over there, buddy. There you go. Oh, no, he's getting there. Okay. All right. Okay, so as you get there, we're not going to stress like fancy terminology except when we sort of have to. So one of the things you want to be aware is that when you're solving a machine learning problem, right, the place you work is called an environment. And the reason I mention that is because the ones at OpenAI are called an environment, and I don't want you to get lost when you eventually get there. Okay? So we built ourselves a little environment, which is the maze. And what we're going to ask ourselves is, how are we going to attack the maze and find our way through? So if you're in the notebook, the way this works, when a cell has code in it, you can push the little run button, and it takes a second at first, then it goes quickly. It can go ahead and run. Okay? So if you can find the part that says, let's have a look at the maze, and run that, you'll get a little like ASCII art maze. I know, I fixed it up. Hey, I'm working. We shared this with a bunch of teachers. We wanted it to be worthwhile. Oh, yeah. You want to, you got to make a copy, I think. Did it ask you to make a copy?
It'll ask me.
So you hit like open in playground also?
Yeah, so you can say open in playground mode so that because it's you can't change my notebook. And then I think you can say save a copy perhaps, and it'll put it in your Google Drive. Does that sound right?
Because it won't let you save it.
Save a copy.
Let's do that. Yeah.
Create a copy, save it.
Save a copy. So that copy is yours forever, and you can totally mess with it, okay? Huh? You can do whatever you want.
Like open in playground and then like, oh, you can
How do you see the names?
Huh?
You got one of these. I didn't know.
You find your way? Good.
That one? Is there more?
There's little mazes not popping up.
These little mazes isn't popping up. Did you push the first one that said run me? That's okay. Now go to the next one that says let's look at the maze.
Oh, it's this one. Oh, okay.
Yeah, that first one doesn't give a lot of feedback. Sorry. I'll fix that.
Yeah, it just says this maze environment is all set to go
All right. Yeah, it's actually.
Is there code hiding behind it?
There is. Double click on it. You can see it. It's the entire environment.
Fun to look through.
So later on, when you become more curious about how it all works, please double click on that. Okay?
Why don't you do it now?
The whole environment's sitting right there,
Oh,
including the 3D plotting that we're going to get to in week 2. So, oh, come on, we made that better too. Okay, so let's just get accustomed to how CoLab works, okay? You can work your way through these cells one at a time, right? This one says, stepping through the maze. That's telling you how to do something. And this one you can actually run. You run it, and it does a thing. In this case, it takes that first step that Sophia took. It happens to take the very same step. It numbers the steps. So you can see, it went from 1 to 2. Okay? Now, in the next one, I had a mental model of the maze, right? So if I know what a maze is and I've seen this particular maze, right? I can do that. I know, pretty cool, right? Yeah, you have to walk through them. So that's an important point, guys. If something's not working, it's because you have to execute the cells in order, because the Python interpreter saves, right? So it remembers where it is.
How do I? So like go through it if you didn't push any like little arrow and play buttons.
Right?
You can also click run all cells.
No, but then you'll just be 3 weeks of the course. All right, so let's all try to get synced up. See the screen up here? Can everybody get to that step, or is anybody not able to get to, hey, I looked at the maze and solved it by hand? Because that's our jumping off point. Did you get there? Yep. You guys? Here, yes? All nods? Anybody not there? Good. Okay. So we, probably expected that we could solve it by hand. Now we got to find a way to solve it not by hand. And here's the philosophical question. I write these because some people use these without a person in the room. If you guys miss a week, catch up. Right? Is being a maze expert really necessary? And we kind of talked about that. The more you know about mazes, the fewer problems you can solve. Assuming you're a computer and you've got nothing but time and you work really fast, right? So the bigger maze expert you are, the less likely that checkers and backgammon and driving a car are something you're going to accomplish. So being a maze expert is a double-edged sword. I know it was fun to solve the maze, but you know what? Now we can't do anything else. Let's take an entirely different approach, okay? And when we take an entirely different approach, this is where we get accustomed to how an environment works. So the way an environment works is the environment represents the problem. You can think of it like a black box, right? And we can give it commands, and it will respond to our commands. And our environments look exactly like the OpenAI environments. So if you can work with this, you can work with OpenAI. And we built it that way on purpose. Even our robotics, whoever's going to be for robotics, our little plastic robots work just like OpenAI. Right? So you get some skills, off you go. That's the plan. So does anybody want to come up here and push these buttons so that I can walk around a little bit? Oh, thank you. You have a reputation for pushing people's buttons, but that's okay. Okay. Now we've got 3 lines of Python code, okay? And what do they say? Because I don't want this to be a mystery. The first one says env equals. Can anybody read Python fluently enough to guess what that did? Not you. You're the teaching assistant. Okay, yes. And help me with your name.
Jack.
Even though I know you're Jack from crew. But that's help me anyway, because it'll help the other people to say their names. Jack. Jack. What does it do?
I think that it's setting the environment, it's telling the computer that the environment that it's in is the maze.
You're absolutely correct. Yes. And just to break it down even to little tiny bits, right? env is a variable, right?
Yes.
And to be a little bit careful with language, that it's an instance of the maze environment. So we made one. Do those words sound familiar? Okay. So that line makes a maze, right? It is a constructor. So it is a special kind of method that constructs an object. Yes. The answer to is it a method is yes. And if we have time later to do some object-y stuff in Python, we will, but we don't need any object-oriented programming to get through 3 weeks. But if you're curious what it does, while we're talking, go back to the first cell, double-click it, and look at it. See it. Okay? Because I know you're not going to sit still until you, off you go. Okay, the next one. Okay, the next one does something really strange, right? You could probably guess what the right-hand side does of that expression, right? The right-hand side says env.reset. Who wants to take a crack at that? What does that do? You've been here before.
I can answer the easy questions.
Go ahead. What does it do?
It resets like the environment to however the constructor sets it up.
Right, its initial state, right? Right? So that seems okay, right? Because if you're going to try a problem over and over, you kind of need a reset, right? Otherwise, how are you going to try the second time, the third time, the fourth time? You're going to be stuck. Okay. So that does a reset, but it also returns a value. And this happens in Python all the time. Something will return a value, and you will have no idea what it means, or what it is, or what it's shaped like, or what it looks like. Okay? So programmed in a language that isn't Python, like Java. Right. What does Java do? Java let you get away with that? No. Right? No. Java would say, look, unless you tell me exactly what you're up to and give me all the details at the beginning, I'm not doing anything, right? Right? It's what's called strongly typed, right? You know what? Right, no, it's just like, zzz, not doing it. This is the opposite. Python says, I'll try my best to do what you might have meant, no matter how disastrous and unintuitive the results, okay? So Python will just literally go, I don't know, maybe he meant this, right? And, you know, it may not, you get some really amusing things happen. So what you do in Python, you don't know what it is, you just print it, right? You print it. Or maybe look at its type or something, but you gotta do something to inspect it, because Python's going to throw things at you all day long. You're never going to know what they are. So the last line of code that prints it, right, it comes out in, what's the value? What did it come out as? Someone who hasn't said anything? Anyone? What did it come out to? 0, 0. And help me with your first name. I'm really going to work on this. Drew. Okay. Michael. 0, 0. So a machine learning environment will only ever give you what's called an observation. An observation is, I'm looking at my problem, and here's a description of its state. Okay? So, in tic-tac-toe, the observation would have to describe somehow where are the x's and where are the o's. That's the state of the game, right? A chessboard would have to say, here are the pieces. So what is the maze telling you? Even though you don't really need to know what it means, yes?
I guess the origin or the...
You're absolutely correct. Right. So it's giving you the coordinates of where you began. Right? Now, as the course progresses, we'll learn that we can think about it as the coordinates, or we can think about it as just the state. Right? Because as you start to imagine how this works, the less we need to know, the better off we're going to be. But for now, it is in fact the coordinates. Okay? Now, an environment will give you a couple of other clues. so that you can start to attack a problem. Because you have to pretend for a minute that with the program, you don't know it's a maze. All you know is you got 0, 0. Like, thanks, right? So this next thing here, it says, could you please print the state space? Go ahead, give that a shot. Right? And what did it say? What numbers did it spit out? Okay, and who wants to guess what that means? Sure. You're correct. So in very general terms, it gives you the size of the problem, if you don't know what the problem is. And in specific terms, it gives you the limits of what you're able to do. So it says, hey, you know what, the problem is this big. And what's your first name? Jordan. Okay, Michael. Okay. So Jorgen's right. It tells you the size of the playing field, right? You need to know that because when you'll see that the only way you can program something to remember, learn from experience where it has been, is if you know how many places it can go. Otherwise, you won't know how many places you need to put things. Okay? Keep going. This is the last thing that an environment's going to tell you, right? And it's the question that I asked when I was pretending to play tic-tac-toe, right? So these are the actions, and what do you think those things mean? So you said that with a model in your head of a maze. That's fine. Which directions you can move. It's correct, right? It's correct. In machine learning terms, in more general terms, what does it tell you?
What you can do.
Yeah, these are the actions you can take. You don't even need to think about what they do. You don't need to know, right? All you need to know is that when you take an action from a state, something happened. It might be good, might be bad, might be a nothing, right? But you need to be able to keep track of that. So before I go on, can you guys now imagine the maze in a little bit of a different way? Okay, let's try to add a piece of code to our notebooks. So go on down. Oh, and there's one more little run that shows that you can also get the actions as numbers. Okay, well, that's just for convenience. But I want you to see how the notebook works, because sooner or later something's going to occur to you, and you're going to say, wait a minute, I want to do my own thing. I want to try that. I want to print that. I want to mess with that, right? You can completely do that. There's a little button, if you hover there, that says, just right on that boundary here. That's hard to see. You hit plus code, right? So what I'd like you guys to try to do is add a code block of your own. Make your own instance of maze. Try to take a step. Try to print the maze. If you print the maze object, it'll make the pretty picture. Give it a shot.
Did you just want us to make the maze?
Make the maze, take a step, print it, just to see that it can happen. Just wing it, it's Python. Why not? Sure, hit run, see what happens. You're not going to break it. Oh, there you go.
Do we have step in here yet?
Yes, we do. Give it a shot. They're all the same. All those environments work the same way. All right. Okay, so go up on screen right. Okay,
No, but I mean like make it move its position.
I'm looking for an excuse to show how the screens work. So pop it up on screen right. And somebody in the back there, anybody? No, you've already helped me. It's Isaiah, is that? Okay. Can you put your screen up on screen left? Do you know how to do that? I just want to show you how the classroom actually functions. And it'll give you a little guidance if you need me to about what you're doing here. Cast, and then just hit screen left. You sort of steal it. Watch this. You sort of, and then hit it again. And what's going to happen is your screen's going to wind up here. See? Okay. All right, so where are you? Oh, you're down below. Did you try to make your own code block? Okay. So put the mouse right about here. on this little boundary here. A little bit further down. Whoops. Oh, you got to go down to the bottom of the cell. Down. Yeah, there you go. Whoops, go slow. You got to be in between two of them.
It's like right above what exactly does the values represent?
It's magic. See, hit code, right? Yeah. And then just say A equals maze paren with a capital M on maze. There you go. So, okay, if you run that, you're going to get a very strange result, which I would love to see. So now say print A, because no, make it big. It's going to help. Say print paren A paren. And you get a prize if you can tell me in advance what that's going to do. That's a Python thing. Well, if you just say A equals maze, print A, go ahead and run that. Just right here. Yeah, just give it a shot. So Python tries really hard. It's like, oh, you're looking for the class maze. Here. Right? You didn't actually make a new one. Because to make a new one, you have to call the function. And to call a function in Python, you have to put parens, empty ones, after maze. So go ahead and put those parens in there. Open, close. Now run it. Just go ahead and run it. Now you made a maze. Okay, good. Emily, you had a question?
Yeah.
What is it? Well, that's not a question.
Yeah. It's a general thought.
So show me, where did you make a maze? Look what you did. That's really funny. That's really good. Talk about good mistakes. Well, what you did, okay, I'll tell you what. Who wants to read this one? Okay, here's apparently what happened. Here's apparently what happened. Emily did her maze, and then she took a step, but it didn't go.
Yeah. Oh.
So there's a couple things there. And can you hit Control a couple times so that we can have a better look at that? Because that is a priceless. I love that error. Yeah, and then scroll a little bit. If you scroll up and down, you'll find it. It'll come back. There it is. Okay, what the heck did that do? Take a guess. Anything. That's a good guess. It may have, it may not have, because for one thing, Emily used env to take the step, right? And env is not this maze. Okay, because it's Python, and it's not like Java. When you run a Java program and it ends, it disappears, right? Yeah. The Python interpreter keeps everything. That'll be there next week, right? So you're using the env from above, yeah, right? But print maze worked. And why did print maze work? Because you made one, yeah, and you printed it, right? You didn't do anything with it. Let's fix that up, okay? So maybe we should take this instance and give it its own name, like x equals maze or something. Yeah, anything, or y, or whatever.
Like that?
Sure, yep.
Do I need the parentheses too?
Yes, Isaiah proved that. Okay, now do print x. Go on, you're doing it. Right. And then do step 2 and then print x again. And program when it's done, yeah. Then print x, sure. You got it. No, you're right there. All right, what does that do? Almost. Let's go look back and look. Well, the first print maze can go away completely, right? Right? And this is the classic Python interpreter situation you've got yourself in. Which maze did you ask to take a step? Yeah. You've done that? Just get x dot step. Yeah. You've now stepped that one so many times, gone off the right-hand side long ago, okay? So you can either print env and see the amusement that it's been stepping this whole time, which is probably worth doing, or you could just tell which one did you mean to step, which instance of maze? Oh, okay. This line right here, yeah, says make a maze, yeah, and call it right. X. And this says print that one. Yeah. And this says, remember the old one?
Oh, yeah.
Yeah.
So if I change that to like maze?
Which maze would you like to take this down?
Does it matter?
Yes. They're different. They're separate.
Well, I want
You want the one you just made, the x one. Change it to x dot step. Yeah, try that. No, now run it. Oh, that's better. Yeah, all right. Okay. Yeah. Very much. Do you want to put your screen up there?
No, I was wondering because
Go for it.
Python is extremely case sensitive. It's totally case sensitive. Everything. Yep. Yeah, all modern languages are case sensitive. All right.
binary
No. Okay. All right. Does anyone have any? Huh?
I minus equals minus 1 for an iterative.
I
Minus equals minus 1.
I minus equals 1. That's I plus equals 1? Who does that?
No one.
Okay.
It's a joke.
Okay. Most of our jokes have to do with picking on JavaScript. That's our natural, that's our go-to.
I don't blame you.
All right, so before we go on, does anybody have any questions about making a little tiny code block that does at least something? Did it work? Did it sort of work? Yeah, good. Okay. All right. So now that we can do something, right? Let's scroll down a little bit, right? And now there's something that's important to discover. And that's, did you have a question about the environment? No. Okay, so this is the last thing about the environment. And this is kind of surprising and strange, but after we go through this little bit, you know everything you need to know to solve the problems that people working on their PhD or getting written up in their times are doing, okay? Because the problems are all rendered in the same way. Now, those problems are far more complex than the maze, okay? But the mechanism is the same. So when we reset the maze, can anybody remember what we were told by the environment? It gave us something.
Your observations.
An observation, and that initial observation was 0, 0, right? So when you take a step, what has it got to do? It's got to give you a new observation, right? That tells you what your new state has become. And if you guess it's probably the coordinates, you're right. It doesn't need to be. It could be anything, okay? All right? It's going to tell you 2 more things, too. And this is kind of, if you think about it, what else do you need to know? When I made that first tic-tac-toe move, what did I need to be told? What happened to me? I made a very dumb move. What happened?
If something good happened or something
Bad happened, right? And the last thing I need to know is, who's ever played pinball? Like a real pinball machine, right? So that one light you don't want to see says, that works? Yep, you know what? That's probably the one light you don't want to see. The other light you don't want to see is game over. So now think about it, right? If the environment says, okay, here's the new place where you're at, right? Something good or bad happened, or maybe nothing, whatever. It's a number. So a positive number is a good thing. Negative number is a bad thing. 0's just a thing. And then there's a little Boolean, true or false. Is the game over? If the game's not over, you know what? You can move again. Does that make sense? So if you were watching a game and trying to tell someone what was going on, you'd be like, yeah, you're still going, nothing happened, right? But you're over here. Sort of, yes. It's like being a dungeon master in a really boring game, right? It's like that. Okay. So, right, so here, very specifically, right, when we took the step, what did it tell me? Somebody who's not been speaking up. What did it tell me? Anybody? Well, find that cell. Is this someone?
That's me still.
Okay. What is it telling me there? And it says it in right here. What does it say? Well, it says, literally says, I'm about taking an action called east. Here goes nothing, right? Sure, whatever E is. Oh, well. No. My new state is what? Yeah, so it turns out it moved over, but it doesn't matter, right? It's just a state, but okay, I moved over, right? My reward or penalty is Nothing, because nothing happened. I didn't bump into anything. I didn't find the exit, right? Okay. Am I done? Okay, so here's what I want you to do. Hack on this piece of code so that this comes out that you are done. Okay? So just change, yes?
I'm still a little confused with how the environment thing works.
Okay.
Like when you're using environment.reset or environment.
Okay, let's talk. That's a good question. Let's talk about that, okay? Okay, so if we had, you ever play Monopoly? Okay, so the box, that's the environment. Okay? You set it up and you count out all those crazy bills and you lay them all out, that's reset. You roll the dice, you make a move, that's step. Okay?
How are you telling me, is the maze part of the environment?
Yes.
The maze is equal to
Yes, the maze is the environment. Guys, shh, shh, shh. Guys, quiet down.
this all is compiled, like every step that you're showing us is together in like one script, right?
Yes.
Okay.
So let's take that mystery away. We don't need to live with that mystery. Let's take it away right now. So throw your screen up here on screen right. Right? We don't really ever have to have any mysteries. We built this, right? We can change it.
Oh, I took left.
Yeah, we can take.
Only take left because I don't want to do it.
Yeah, Jack, take left. Amelia, also a rower, needs you to take left.
Is there a way to like make the program go back to its original state?
Yeah,
I made a mistake about how.
you put yours up on screen right. We'll get to you in a second. Jack, you're first. Is this?
Yeah.
Okay, go on.
If there was nothing in the Python script,
Yes,
and I said environment, it would just do nothing because there's no environment whatsoever.
that's correct.
Just doesn't know what
We're
It just doesn't know what it is.
gonna do it on your computer right now. So go to there's a menu somewhere that says, hey, you know what? Reset the kernel. The kernel is the environment. See it there? Runtime. Sorry, runtime. You'll find it. There you go. We just reset all. Restart. Exactly correct. Restart runtime.
Restart runtime.
Yeah, just go ahead, do that. This is doing what you just asked it to do, just cleared everything out. So now if that happened, and you click and you try to run this right here, go ahead, try it. Go ahead and run it. Doesn't work anymore.
Okay.
Because it no longer knows what the maze is.
Okay.
Now hang on. Go ahead, you go first.
No, go ahead.
So no mysteries, right?
No.
Go to the top. Go to the top of the thing. Right? Oh, look at that. You opened it. Good for you. That's the maze.
Okay.
Now, a Python interpreter maintains its state. So the minute you run that cell, it stays in the interpreter until you kill it. So as long as you run it once, it knows what a maze is. Make sense? Go run it once. And once you do that, you see it says the environment's all set to go. Right? I put that in there. So now everything that's in that script is in the interpreter's memory and namespace and everything. It's all stuck in there. So starting to become clear? Later in the course, we'll get rid of Colab. We'll just fire up Python in a terminal. And like do it like bare metal, and you'll really see it. Okay? But before we go on, that was only part of your question, right?
I think I got it now.
Okay. So now,
So if you just took the maze,
Yes.
and you did something,
yes.
and then you just reset the maze. Okay. No, I answered my question.
Good. Now hang on. I'm gonna impose on you though for a second, okay? Make a little code block for me.
This one, oh.
Because this actually gets to a question someone else had a moment ago. So yeah, if you can hover in there, yeah, go make a code, excellent. And make two mazes, call them, A and B. So there you go, A equals maze. It might have been Emily's question, I don't remember. B equals maze. Okay, good. And so then after you do that, right, we're going to print A and print B, and then we're going to make different moves, and then we're going to print A and we're going to print B.
Okay.
Because these are totally separate mazes.
And can I just do that up here?
Sure, right there. So print paren A paren. Go ahead.
You said print what?
Yeah, you got it. Run that right there. That code's perfect. Run it. Just scroll down. See, that's maze A. Now, if you add another line, print B. Go ahead. And they're going to look a lot like each other because they're both reset, right? Okay. But then if you change A, like A step something, A dot step.
Okay, so I have so
Go on.
if I do environment dot step, is that changing the whole, like the stored environment that's there? So it won't change A or B, but it will change.
Well, ENV was a maze.
Okay.
Just like A is a maze and B is a maze.
Oh, we'd say.
ENV, we happen to call it ENV. That's a little bit of like a habit that machine learning people do to make it generic. Might have been better to call it M or something. Okay. I can see where that would confuse you because it's not the environment, it's an instance of the environment. So A is an instance of the environment, B is an instance of the environment. Yeah. You're good mess with it. Okay, Max, your question. What was it? What'd you do?
I changed this to like maze or something, and then I tried changing it back, and then didn't fix the problem.
Well, the way your code is written right now, you wish you had a maze called ENV, right?
Yeah.
So insert a line above that line. Make a line above this one. So make a new line in the middle here. Python. Go up one. Yeah, make a line. There you go. And say ENV equals maze, paren. We'll just make one. It's Python. Capital M on maze. Yeah, now run it. Try it now. See? So it's very Python, right? You're like, oh, I wish I had one of those. I'll just make one. Right? Which you can do some horrifying things, right? But it also is super convenient, right? Yeah? Good? It does. Sorry, Max, does that make some sense? Yeah. Okay. You can name it something else. Yeah, no. But it's funny. Okay, so guys, the original idea was to make a step that caused the game to end. Has anyone done that? Okay.
2 minutes.
Take your time. How to get a random integer?
This is not See?
Oh, who is that?
That's not me.
The environment gives you one. I should have told you that.
Oh, the sample. I forgot there's the sample.
The environment code is really
I guess maybe you just thought ahead and you figured out what we're about to do. That's awesome.
Well, I was just going to guess. I wanted to see if I could get it to just go somewhere random.
You absolutely can. So one way to do that in the environment is to look up, search in there for sample or sample underscore n.
I can search?
With Command F.
Oh, Command, okay.
Yeah, you could just Command F in there. Sample, the word sample. Oh, wait a minute, look. Wait a minute, the environment has a method called sample. Let's pretend Michael's not here. I wonder what that does. So do print environment sample and run it a bunch of times. Right?
Oh.
You did? Good.
That's so good.
See what that does?
Well, I don't know
Right?
if it actually works, but it does say done is true, so.
Jack, your instincts are very good. Right? Just go look.
What's the difference between sample underscore and sample?
One of them returns a letter. They're interchangeable. One returns a letter, and one returns it in numeric form. Because as we progress with the lesson, we'll need both. But in terms of conceptually, they're the same thing.
So if I do
Print a.sample, just for fun. Oh yeah, a.step. You're right. Then I think it's probably a.sample.
Oh yeah, a.sample.
I'm not totally sure, actually. Well, you get sample paren because it's a function, right?
No, you have is good.
Yeah, Jack, no, you're in the right place.
You just call it a method, so you need to open and close parentheses after it.
Okay. Oh, thank you.
Sure, give it a try.
There you go.
Now, let's see if that works. If not, we'll have to go look where sample really lives. Did it work? Now, if you run it again, it should take some other random step because it's random.
It's still just deciding to go off the slide. Wow.
Well, keep trying.
Wow, that's like a bit. It wanted to just.
Yeah. It's 50-50, right? So, you know. All right. So far, so good. That is a machine learning environment. That's all there is to it. Okay? You can solve incredibly complex problems or really simple problems. Doesn't matter. As long as you can reset the thing, find out what your observation is. Your world looks like this. You can do these things. Something happened. Is the game over? That's it. Before we try to move on, and we're going to take a little 2-minute break, but before we try to move on, are there any questions right now?
Can you reset to not the start state, but like a previously known good state?
That is actually a really astute question. You can, depending on what sort of training you're trying to do for your algorithm, you can cache states. So since you asked, there's this amazing blog post called Pong from Pixels, written by a guy named Andre Karpathy, who's like a luminary in the field, right? And he developed a technique to cache the screen image of that old-fashioned Atari Pong game, right? And then to use those cached images to write a machine learning program that, not knowing what it was doing, learned how to move the paddle and ultimately play the game after millions and millions of tries. So sometimes it's really necessary to cache states so you can review them for training purposes. Typically, the reset will always bring you to what's considered an initial state, but in some environments, that won't always be the same state. Depends on the problem you're trying to solve. Okay? So if you're trying to solve a problem with a ruling, but your initial state might be you're up there somewhere, right? Because you wouldn't want to only be able to land from one place. Like, good luck to the astronauts, right? If you have to be in exactly the same place every time. So we will see problems like that later on. But that is actually a really deep question. And you'll see some of it as you progress, okay? All right, guys, let's take just a couple-minute break. The ladies' room and the men's room are there. There's water over there. We'll come back in a little bit. We'll keep going, okay? I thought you said something. Oh, sorry. Yeah, he's just throwing his words.
How I revert it, because I did a bunch of stuff to it and I wanted to put it back, but I don't know how to put it back, like coding it.
So apart from hitting undo, 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 right, you can always just go back. You can go back to the original link and just grab the whole notebook again. Yeah, well, you can because you can't change my notebook. So yeah, but you can rename your copies. You can call it Higher Math 1, Higher Math 2, Higher Math 3. So go back to my link. Oh, save a copy and just call it whatever 2. Yeah, you can't break it. It's unbreakable.
So I have a question.
Yeah. Yeah, no, have a question.
So if you say computer function dot reset,
Yeah.
or the maze dot reset,
Yeah.
give you the location of it. What's the dot reset function do for this instance?
So it does something and it returns something. The thing that it does is it puts that instance into its initial state. So just like the Monopoly board, if we put all the pieces back, hand out the money again, ready to go. The thing that it returns is an observation of what that looks like.
What happens if I just want to return an observation and don't want to reset the state?
So every time you step, you also get an observation. So it's your job as the computer scientist to not lose track of those. So here you.
What happens if I just want it? If I just want the observation? Like if I just want to know the exact location on our state, in our overall state.
Right. So because we see every step, and every step gives you the observation, it can't get away from you. Does that make sense? But I'm going to run a session during our little break here to show you what I mean. Okay, Jack?
Okay.
Because I'm going to run this a little different way. So Amelia, I'm going to use that computer. Oh, you did? Oh, nice. That's good. All right, Jack. So we're going to have to do a little different style of computing to answer your question. Okay, Jack, can you see this right here? That's a tremolo.
Yeah.
Okay, so here we go. So, there's the maze of raw Python. Okay. So I'm just going to do this. Watch this. I'm going to hop into Python. You ever do this?
Yeah.
Okay. From maze. We'll get back. How did I lose my screen? My Chromecast crashed.
I stopped casting and that might have been really good.
Okay.
I have a question.
Oh.
So, okay.
I messed up that, that's how I
All right, back in action. So now, let's answer your question in a really specific way, okay? So in my terminal window, I'm going to make m equals maze, right? If I do m dot reset, it gives me the observation, right? If I say obs equals m dot reset, I've captured the observation in a variable called obs. As long as I've captured it, it can't get away, right? Okay, now, if I say m dot step and I take some action or other, right? It gives me a series of return values. And those happen to be an observation, a reward, and a flag to tell me whether I'm done. We're going to see this over and over. You'll be able to do this in your sleep. It's my responsibility when I take a step to capture those things so I can use them. If I want to have a look at where I am because it's fun to know where I am, I can do that. Okay? So sometimes the raw Python set has a lot recommended replit. You use replit? Replit? So since you asked, go to the website repl.it. This is another online coding environment, but it's more interactive. And if you can log in, repl.it. IT, replit. Yeah, try that. Trust me, it's weird, but trust me. Now, this is the coolest thing ever. Watch this. Good. Give it a shot. Yep. Yep. You can write in any of these 100 languages right here and try it out. I'm here. Yeah.
Do we set so we have a random
Yeah.
variable? Is there a way to reset it like chronologically so it resets the random variable after each repeat, or will it?
Sure there is. Go up on screen right and we'll talk about it.
Can't you, wait. Can't you just say like else or is equal to negative one and reset it back to the.
I'm trying to print it, but the initial thing won't even let me print it. I made a fresh copy.
Yeah. That's because you have to run the first cell to load the whole thing. Yep.
Do I have to do all of them or
Just that very first one. That very first one loads up the whole system. All right. So what are you trying to do?
Okay, so I wanted to not keep going in the same direction.
And then that resets.
Okay.
Like the randomness, it will only go in one direction. It will never change.
So wait, what is it doing and what would you like it to do?
So the random number, it doesn't reset after each movement.
I think it does. They're using sample?
Yeah, but I'm not. Oh, should I write a new sample?
Oh, yeah, no. Just x.step, x.sample n. And every time you call sample, you get a new number. So you're trying to solve it by a random walk, right?
Yeah.
That's awesome, because that's the next part of the lesson, but you do it.
Wait, so do I just set object, instead of writing s, I just put x sample in there?
Well, here, every single time you call sample, you get a new sample.
Yeah.
Right? So inside of your step, you call sample. Then every time you step, you'll step at random.
Is that on the right?
There you go. Yep.
It sets sample to a variable and then.
So sample is a method that returns a sample action from a random uniform distribution. Okay? Which just means everybody gets an equal chance and something comes out. Now run it several times. Yes, it did. That's a problem, actually. Yes.
I have a question.
Good.
So I'm trying to get it on the left screen right there.
Yeah.
I'm trying to get it to see if it steps inside the box, it will return either true or false.
Yeah, I see that. Okay.
What's wrong with it?
So if a step, right?
Yeah.
A step is a function. What you were perhaps trying to do is you were trying to get the return values from your original call step.
Yeah.
So if you don't know what those return values are, a little side trip is say print a of step of sample and see what it gives you back. Okay? And then we'll figure out how to capture those values. Okay?
Are you getting numbers? I want you to repeat the process. I want you to repeat the process 1, 2, 3, 4, 5 times.
Yeah, Jack, run that. That's okay.
I have one too many.
It's adding the number in.
You owe me one closed paren. There you go. No, one closed paren. Run that. So we give you this stuff, right? And of those values, you were looking for this true or false value. Did you want to know if you were done?
No, I wanted to figure out if I was inside the overall group.
Inside the.
Yeah, you're missing. I'm trying to figure out if it's in this the state underscore space. If it's in the overall state.
Right.
Out.
I have great news. Guess what happens if you step out? You don't need to, right? You lose. You don't need to worry about that one. Yeah, that's right. Go do the step 1 second. Do the step. Do a step. At the very beginning, just step 1, and it'll go out of bounds, and you'll be good.
Oh.
All right. Good.
Okay, I was trying to set that up.
All right. Did you have a question back there? No. Yeah. All right. So here, guys, we're going to try to focus again. One more thing we're going to do. You ready? One more thing we're going to do. No, yeah, sure, or just scroll from there, or I don't even know who that is anymore, whatever. Thank you. Right? So you guys started to work intuitively toward the place we're next going to go, okay? Which is what is maybe the least efficient, but the one foolproof way we can solve a problem like this if we have infinite time and our computer is really fast.
Try every single option.
Yeah. In this case, we just try them at random, okay? So now, that's right, that's not a small distinction. In artificial intelligence, there's a whole bunch of ways to do things that are called generally like divide and conquer. And that's when you try what you might have been thinking, which you forcefully try every single one because you figure out which one's which, right? So in order to do that, you need a model of the problem. So if you wanted to take a chessboard, you put a knight in the chessboard. You wanted to go around and hit every square, right? Without hitting a square twice. That's a problem you can do. If you know about knights and chessboards, you can just forcefully try every possibility, right? If you don't know, you can just randomly move the knight, and if your computer's fast enough, it'll take centuries. If your computer's fast enough, you'll get it, okay? So we're going on the my computer is fast enough approach because the problem's not very hard, right? So where you guys were headed with the random walk, we're going to do that, I think, if that's what's next. So go ahead and scroll on down, okay? Solve the maze with a random walk. That's sort of curious. Okay, solve the maze with a random walk. So try to find your way to this place, okay? And guys, remember the sample that you invented because you needed it? I finally got to the point of introducing it at this point in the lesson after you already invented it for yourself. That was good. Okay? So the actions, we can either use nicknames or numbers. They're interchangeable, right? And there's a little cell here that does something special in Python. Does anybody know what those square braces, not you two, mean in Python? Square brace? Huh? You're supposed to. Ilya. All right, Ilya, what do the square braces mean? List. It's a list. Yeah, it's a list. All right. Lists are good. Python does all kinds of crazy things with lists. Okay? All right. So this is a list of random moves, right? And then here's the first really heavy-duty piece of code. And all we want to do tonight is get through this, right? This piece right here. So it says once you have random actions, it's easy enough to take a random walk. But what does that code do? Even one line at a time. In fact, if anyone ever does, if you're in college and you take computer science and the instructor says, what does the code do? Answer really quickly. Because the first line is usually pretty clear. You get to about the 8th line, you're like, right? All right, so, well, what does the first line do?
It makes a new maze in a variable environment.
Yeah, it makes a new, thank you. Okay, you're done.
Nice.
All right, so it makes a new maze. What does the second line do? Yeah, you're done. Resets the maze, right? What does the third line do? Go ahead.
It sets a counter for total steps taken.
That's correct. And in Python, the counter becomes an integer because you made it one. So it's not like you had to say, int this, that, right? Python's like, okay, fine. If that's what it is, that's what it is. Okay? Total steps is 0. What does the fourth line do for someone who hasn't said anything? Yep. And how long does it run for, apparently? Well, what does while true mean? It's a trick question. I don't mean to make trick questions. What does a while loop do? Anybody? How's a while loop? Yeah, Max?
Does it maybe go through all the possible options?
Yeah, it continues to loop while a condition is true. So while I'm still hungry, give me a cookie, okay, is a reasonable thing, right? Eventually it'll stop, right? But this one says while true. That's going to loop forever, yep. It's, until we encounter a break statement. A break statement will say, all right, enough of the loop. Okay, guys, so you guys focus, right? How about line 5? What does line 5 do? Exactly, you win. It's a comment, right? And plus, you don't have the answer again. All right, it says, yeah, you know, we're going to take a random step, right? And I put that there because line 6, which is pretty much the entire program, is kind of complicated, right? So who wants to start to pull apart the one line that does pretty much all the work? What does line 6 do? No, you like this line? Jeff, no, get it. All right. So Amelia, what basically does line 6 do?
It sets 3 variables, like the observation, the reward, and whether or not it's done, from one step of any random option.
That's correct, and that was well said. I'm going to read it the other way. In case you don't know what it does, you can always read source code, ready? From right to left and inside out, okay? So I don't even care about this side. Can you make that bigger?
Yeah,
because I'm going to get there later. That's the return value, right? If I don't know what it's doing, yeah, it's like the $4 keyboard from Amazon.
I really struggled.
Okay, so here we go. Ready? Yeah, there's an option called turn line numbers on in there somewhere. I don't even care about the return values. You guys good? All right, come back here. All right, inside out. I'm going to read the innermost function first. The innermost function is environment sample. If I don't know what environment sample does, then I've got no idea what the line does, because that's what gets executed first, right? It's going to do the inside part, just like in math when you put a function inside a function. It's going to do that first, right? Okay, so what does environment sample do? You just play with it. Returns. Takes a random step, right? So now I'm taking the environment to step that step. So I'm taking a random step. Okay. Now I'm catching the return values that step returns, which is the observation of the new state. It's a random walk, so do I care where I am? Not particularly, right. It's kind of like, in fact, when I was in school, it was called a drunken walk, because you could say that back then, okay? Or Brownian motion, same thing, okay? So you don't care where you are, because the next step's random anyway. Do you care about the reward? Kinda. What does the reward tell you after many thousands of steps? What happens when you only get a reward of 1? What happened? You finally found it, right. At random, yeah. And then you do care if you're done, right? You do care if you're done, because if you're done, you got to start over. If you're not done, you keep going. What?
Nothing.
Okay. What's your discovery? Oh, no way. Oh, okay, we need a break, guys. Hold it. Go do it.
There's also power that you can set that sets off like a bunch of sparks.
Everyone take a break and go to Corgi mode or whatever. Don't miss out.
Round of power and typing.
I don't know. Maybe it has something to do. Hang on. You do that. I'll see how much time we got. We're doing fine. We have plenty of time for Corgi mode. Kitty mode. Let's stay in animal mode for now.
Set your power to many power.
What does it do?
What happens? And try to turn
Type.
Or can be negative. Step on the wrong block.
Oh my god, that's so fun.
What happened?
Oh my
Amelia,
god.
do it. Go to settings.
Okay, ready?
Jesus Christ.
Settings.
What compelled you to go to
Miscellaneous
settings?
Power.
Yeah.
Oh, because I was trying to figure out how to turn line numbers on and tell
Then
them.
power.
And then start typing.
Start typing.
No, it's like
write random
write
letters
a code
in
line.
the code, just whatever you want.
Boom.
Keep going. Like type a bunch.
Okay.
Like
It's spam.
just
So I have a question. We may as well take the 30 seconds to answer the interesting question. Guys, why did Google put those in there?
Well, I know power was in April Fool's.
Okay. I have my own theory why Google put that in there. They desperately need you guys. They desperately need you guys to learn how to do this. I'm totally serious. If you think I'm not serious, we just had an intern who was a very bright person who's in her mid-20s, and we started a project and she was gone to Google. We didn't get halfway, we got a third of the way through the project. Okay? They want you to learn how to do this. Have you guys seen the AWS racer? Amazon made a little plastic race car that's reinforcement learning. It's exactly what we're doing here tonight to try to get people interested because they're desperately need software engineers. Like, isn't this fun? Try the racer. Seriously, this is a big deal, okay? So by the time you come out of college, there you go, okay? So. I'm going to try to focus. It's not going to go well, but I'm going to try. All right. What does line 7 do? No. If you want to. Who hasn't answered? What does line 7 do? What does line 7 do? Go ahead. Sophia, what does line 7 do? Yeah, it increments it. So it's keeping track. So you took a step 1, you took a step 2, you took a step 3. Increments it. Right. You're right. You said it right. It's just that was my fancy. Okay. Now what does line 8 do? Are you in like Star Wars mode? Like what are you doing?
I'm getting the combo.
When you're done. Okay, good.
130.
What'd you get?
130.
Well, see, the funny thing is, because your pace is good, we have extra time for cat mode. That's actually kind of funny. Yeah, Max.
It defines when it's complete and then also puts it into like Word instead of coding.
Yeah, so that's right. It's got two things. The if statement says I'm going to do a conditional branch, right? In this case, if I'm done. So if I went out of bounds or if I won the game, if I'm done, and then over here, the comment which I wrote says, is the game over? Okay. If I'm done, now guys, take a good look at lines 8 through 12 and look at the indentation. Can somebody tell me what that indentation means? Because in Python, there are no squiggly braces, right? The indentation counts. Okay? So those all those lines, all the way from 8 down to 12, they're indented in a strange way. Anybody want to, go ahead. What does it mean?
It's what function is a parent or a
Yes.
child to another function.
Right. It's which one's inside of which one, right? Yeah. So in this case, the one that's on the left, right, everybody's inside that one if it's to the right, right? What are you doing? All right. So so if done has what inside of it? The entire if-else statement, right. So if we're not done, are we ever going to go to line 9, 10, 11, or 12? No, we're just going to go back and loop it. And that kind of makes sense because we're trying to go through it random and hey, we're not done, right? That also implies something slightly subtle about the environment, which is what are the two ways it says it's done? You either have to what or what? We lose or win, right. Those are both done. If you lose, you're done. If you win, you're also done, right? So inside the conditional, how do we consider whether we won or not? What does line 9 do? What does line 9 do? What does line 9 say? Come on. Isaiah, what does line 9 say? Can you see it up there? Yeah, it says if the reward is more than 0, you won, right? Because the environment will always give you feedback. In our world, good things are positive and bad things are negative. So I didn't even need to know how good it was. I just needed to know it was more than 0. If it's more than 0, I won, okay? So if I won, I'm done. There's the break statement. Does anyone know what a break statement does? No? No? Yes? You can try.
Gesture towards me.
That was a no.
Gesture towards me.
There was a negative gesture. Hang on. That's right. It causes you to exit whatever is the control structure that you're in. In this case, it's the while true. So your infinite loop from before, it's not infinite, right? If we lost the game, all we do is, and this is for Jack, because this is your question from before. If we lose the game, all we do on line 12 is call what?
Try again.
Yeah, try again, right? Put all the money back, put the pieces back, do it again. So now when you run that, everybody run it, and everybody tell me on your computer how many steps does it take to You did very poorly. How many?
2,600.
A little better.
11,900.
I got 40.
You didn't. You got 40?
I clicked past it, but I got 40.
That's really strange. Yeah, that's very strange.
I'm so sad.
So try to print the maze, because I'll be kind of, I don't even know what the maze would say in that case. But make a new. Oh, you click past it. Okay. Yeah.
You can run to it a couple times and get the
Amelia, what happens if you try to print the, as the very last line, print the maze? So do a print ENV.
Jackson's just better.
No.
You did not.
Oh, I just got 937. No way you got 10.
I'm not sure quite why it says that. I never thought about it, like if you run it 2,000 times. Yeah. 40 will stand as the record, Jack. What? You got 30? Okay, so you got 10? Okay. 10,000. Right.
got 46.
I got 616.
So guys, what math classes are you all in? We covered what we're going to cover, and we have a couple minutes, so we can just goof off. So let's go around the room, starting with my friends from Oyster River. Drew, what level math do you take? I'm just curious. Pre-calc, good for you. Good. Jorgen, what do you take? Trig. What is your first name?
Roland.
Michael. You were quiet all night. It'll never happen again. Jag, what are you taking math? What are you taking?
I'm taking pre-calculus.
Good, okay. All right. Ilya, what are you taking?
Algebra 1. Well, not in school.
Well, you know, sometimes things just don't go as planned. So what are you taking?
Algebra 2 and geometry.
Good, for you.
Reflex. Pre-calc with teaching.
Okay. Nice, good. So you guys are going to wind up with the question I'm going to ask. What are you taking for math? Algebra. What are you taking for math? Okay. So someone can figure out the likelihood of getting through this thing in 12 steps. It's low, but they just did it. I don't know.
I got 15 steps.
The easy way to do it is to count how many steps does it take to get to the end? 7. And how many choices are there?
16.
Well, for each step, how many choices are there? 4. So what are the odds of making the first move correctly?
1 over 4.
And then how about making 2 moves in a row?
1 over 16.
Okay, that's correct. And then how about 3 moves?
So 7 would be
1 over 4 into 7.
So something is wrong with either the program or you guys, because we shouldn't have gotten a 30, right?
It's just so good.
Well, no, there's something else going on too. We are. That's true. I mean, we're that good. But what happens if I move like this? I hit reset, I go east, west, east, west. Where am I?
Same wherever you started now.
Right. Did the game end? No, I wasted time, right? There are a lot of paths through that maze. There are just a lot of really dumb paths through that maze.
you go east west 2,000 times and then walk out.
So what I'm going to ask you to do in the next few minutes is to attempt to count the number of steps that it took for the successful path. Because this question never came up before, but it came up now. We got about 10 minutes. So one more time. The code currently measures the total steps for the entire endeavor. Starts with 0, and when you finally find the exit, it's done, right? I want to know how many steps that one episode where you got through, how many steps did that take? Okay.
CoLab just isn't working for me now. No, that took like 30 seconds to run though. Oh, no.
Google might be getting impatient with us because we're eating up. Give it a try, okay? Take a few minutes, ask questions if you have them.
Gordon had an interesting question.
Which is what?
When you read under that bus.
Yeah, pop it up here. He says that I can't look at the corgi anymore.
You don't like him?
No, he's wonderful, but does that mean the cat's deceased or?
No, the cat's just gotta shake him about his words.
Okay, all right. Yeah, left's good. Yeah, yes, please, left. Get left.
Because then I don't have to show him.
All right, so what's going on?
So the question is my maze, where I go 1, 2, how do I get to 7 and 8? I go down.
You can, okay, first of all, looking at the source code at this point would be a great idea because I think I know, and I'm going to guess, and then we'll see whether I'm right, okay? Whoops. No, go back for a sec. I'm going to guess first because why not, let me make a fool of myself. So, yeah, I'd like to be wrong. So it went 1, 2, 3, 4, 5, 6, 7, 8. Yeah, but it only left behind the last digit that it could print, maybe, because the way I wrote it, who knows? But it definitely went over itself. So before you go there, pop up in a code window, make a new maze, and take a really silly, go north, south, north, south, north, south, and see what it says. Okay? Just try it.
I thought 0 every single time.
6 doesn't seem like enough.
Well, because technically it only takes 6
6,
steps.
yeah, maybe. You keep getting 6 or 8.
Yeah.
Okay.
Literally keep running it until it's 6 or 8. I just had to do a current step equals 0.
Uh-huh.
Every time I ran through one current step, if it failed.
Yeah, so make a list, okay? And every time you make a move, append to the list, and every time you reset, kill the list. So that you have a list of the moves that succeeded, and then print the list and see if it looks correct.
Okay.
So you did it exactly correctly, good. So now instead of zeroing the counter, also make a new list. Every time you step, do an append. Every time you reset, kill the list. And at the end, print the list. So the list will have the steps in it.
Yeah, that's what I did, but is there any way to say print the thing at the end of the list?
Of course there is. Put your screen up on left and we'll figure it out. Or right, no, you're right, sorry, right.
Does this actually work? So I have.
Good!
This is actually printing what I think it is. So I'm a variable correct path,
Yeah?
and then I have it add 1 every time it cycles, but whenever it fails, I have it reset the variable to 1.
I think that is almost exactly correct. Because every time you step, you want to you're incrementing it, right?
Yeah.
Started at 0.
But when I start at 0, I get 6.
I think I had that intuition wrong, which I thought was incorrect. But somebody just pointed out that the right answer might be 6 because when you step on the exit, you win. Are you okay with it? Good. All right. All right.
I have a strange number. I don't.
What'd you get?
It's 0.
I don't like it. You put your screen back. Oh, good. Yes, go ahead.
So I'm back to the 1, 2, I just can't let it go.
No, you shouldn't.
So I would expect when I successfully get it, all I would see is my successful path.
Yes.
Why do I see the 1, 2, 7, 8? Why is that? Must be my last unsuccessful try, I would assume. Does it not just flush? Does it not flush the last?
That's one of the reasons I said maybe there's a problem with the environment. I don't know, right? So now what you want to do is go take a peek at the code and look at the double underscore string, which is the print method, and see what it's actually printing. Okay. Okay.
Is that the same, my question was why you would have two twos, which I think is the same question?
It is the same question, right? And it's a question of whether it's making a notation or whether it's actually relying on the thing. So the first thing I would read would be reset. Like, what does reset do? Because I believe you're calling reset.
Yeah.
So I kind of want to know what reset does, right?
Still calling it 6 or 8. It's doing.
Is it printing the list?
Yeah, you can see it go up.
That's good work, and those look like correct moves. So 6 or 8 sounds okay because 6 is 6, and 8 is it just danced back and forth once.
Yeah, which is interesting that I'm not getting any more of the dance back and forth more than once.
Yeah, it doesn't strike me.
I've just run it
Okay, I
10
got
to
stuff
20
that
times.
works.
Yeah, I'm really curious too. Right? We're going to have to take a close look at it, right, between now and next week and see what it's doing. Right. What'd you do?
I don't know, I got 0.
Got 0.
Well, it's because I'm setting it to be 0 when it's.
Well, you're setting it to be 0 every single time you take a step.
And that's the thing, is I'm trying to figure out in my head how to that.
Well, I would suggest setting it to 0 when everything else gets reset. Hint, hint. Right?
Like set good step to 0 and everything else.
When you do reset, yeah. Give up. Yeah.
But then it's
What's that? Huh?
like, isn't like, don't we want to like make it not do the, like not
No, I was curious about the back and forth. Oh, I see what you were doing. You were trying to eliminate, no, there's no need. I was wondering whether it was doing 18 steps, dancing around and getting out. So that was actually you were just doing more, you're taking a more refined look than I asked you to. Use that. Hey, what's up?
I was just really curious.
Yeah.
And so I printed all of this.
Nice. Those are all the steps. Yeah. Yes, those are all the you printed all the observations.
Yeah, that was unintentional.
That's okay. You didn't break it. All right. All right, guys. In the 4 minutes we have left, any crazy questions? I have one big request. Okay, get on the Discord. Okay, everybody get on the Discord, because during the week or at any time, if you have questions about Python or algebra, calculus, trig, pre-calc, doesn't matter. There's like about 80 people in there, and they're the nicest 80 people in the whole world. And some of them are in college, some of them work with me in developing software. Most of them are high school students, most of them. And it's just a really great place to be, but also as we try to figure out what's going on with the maze say, right, I'll post things in there. So whatever else you do, did everybody here use Discord? I don't know. You're a grown-up. All right, we'll fix it. Would you like to use Discord? It's free.
I got it set up.
Oh, you do? Okay, yeah, it's a chat. It's just a chat service. In fact, you'll notice that there's a teacher from New Hampshire in there today, Sarah G., who was trying to work on a Python example, is an adult. Yeah. Okay, this has been great. We can do anything else? Any questions tonight? Everybody get yourselves home in one piece, okay? Next week, we will try to find smarter ways to traverse the maze besides stumbling around at random. Okay? Good, thanks. All right, what's going on? Huh? What? What? Yeah, it is fun. It is.
It's like good to know,
Oh, oh, I see what a good step is. Yeah, I see what. Yeah, I get it. It is fun. That's what Andre was saying to me today. Because